Should we wait the 30 seconds to make us exactly on time? No, that's it. I think everyone's here. Yeah, so welcome to the first Hack Fukuoka of 2022. We made it. So I'm just going to do a quick introduction for today's Hack Fukuoka and need a pointer, and then introduce what's going on. So what's been happening and what's happening in the future for Engineer Cafe? Well, sorry, let's go from here. Yeah, we had the Dev plus Design Exchange. It's been happened, we've had it twice now, and there's another one coming up in February. So this is kind of Brienne and mine's event to connect up developers and designers. It's a very chilled out event. Come study on a personal project for a couple of hours, ask some questions, get some input from the other side. I've already learned tons about Figma and design for this one, so that's been great. What else have we got going on? Yes, tomorrow we've got an event on GPU programming. So it's meant for beginners. So programming experience is, you need some programming experience, but no parallel processing GPU experience is required. And it's going to be 2 p.m. at the Engineer Cafe, and we're going to stream it as well on the Engineer Cafe YouTube channel. So that should be fun. Given by Chin, who's working on a chemical database startup, so all kind of interesting stuff. And finally, Japanese for Engineers is kind of moving along with some preparation. We've got a bit of collaboration from a local Japanese school, and they're really enthusiastic. They want to do a bunch of events, so we're planning to do 2 events a month, maybe for the next 3 to 6 months. So if anyone's interested in kind of doing some long-term study on their Japanese, I haven't quite got the timings yet, but I think it's going to be on Fridays, the first and third Friday of the month, and it's mainly going to be about communication and practice. So get in touch with me or the Engineer Cafe if you're interested. And there's going to be a couple of different levels as well, so maybe if you're quite advanced and you want to do more business, technical stuff, there's something for you. Or if you're a bit of a beginner, there's something for you too. Anyone got any questions or announcements or anything? No? Let's keep going then. So here's the tricky part. Aaron, can you hear us?
Oh, hello, hello.
We can't hear you, unfortunately. Let me just change the settings briefly. I think the stream should be able to hear you.
Check, check, 1, 2. Can you hear me? Hello, hello.
Okay, can you say something now?
Testing, testing, 1, 2.
Okay, it's not ideal, but we're going to put you through the MacBook speakers.
Okay.
So, okay, what is your big announcement you want to talk about today?
All right, so I want to announce that we're launching a VR challenge. And if I could share my screen, would I be able to?
Yeah, I hope so.
Nope, I need permissions.
Oh. I can turn it on for you.
Okay.
Okay, go ahead and share your screen.
Thank you, got it. All right, so we're going to run a series of 6 VR challenges throughout the year. So slightly ambitious project. And the idea is that VR technology has gotten surprisingly good, and not a lot of people really know about it yet. So the Oculus Quest 2 has gotten a bunch of features that really make it stand out for experimental development, including hand tracking, pass-through, and Microsoft has put a lot of effort into the MRTK, which is like a toolkit for creating really nice user interactions and things. So I was thinking, man, this is so cool, but nobody really knows about it. Why don't we run a challenge to encourage people to try? And so over the past month, we have been working on putting this challenge together. So it will be a bi-monthly challenge. So the format is the first month will be the challenge theme, and there we'll have a workshop where people can come and try their hand at making VR experiences. And then the next month will be like the voting month. So there'll be time for people to try out everything and then also get help. We'll have a workshop, or like a try it participation workshop, and voting on it. And we're actually going to give away prizes. So Steampunk Digital is backing this with a little bit of cash. So roughly a $50 gift certificate for Amazon for the first place, and a couple of pins and stuff for the second and third place prizes. So nothing really exorbitant or anything, but I wanted to put a little bit of pressure to go for it, you know, to really try your hand at some VR stuff. So as I was talking about it with people, it became clear that actually we could run it like a game jam. So we're going to use itch.io as like and run it just like a game jam. We have here some of the, you know, just kind of the usual submission criteria of putting a title on it, a description, setting a license and stuff. So we got all the details on our website at steampunk.digital/en/VR-challenge. So this is the web link. And you can join our Discord, and so come onto the website, it's at Steampunk Digital, and join the Discord, and we'll help with setup and whatever questions you might have. There's, yeah, one of the other things that became apparent is that the Quest 2 also supports WebXR. So, and just rolling out now is the ability to copy and paste a web link through the app into the headset. And this has greatly improved like how you could just hobby stuff. So there's a bunch of tutorials that our developer in-house, Yoshinaga-san, he runs AR Fukuoka. He's done all this stuff on WebXR, and there's such cool stuff you can pull off with the Oculus Quest with WebXR, and like live editing with Glitch.io and stuff. So that's it in a nutshell. I hope you guys joined. Thank you very much for your time.
Excellent. Yeah, I think it's worth mentioning that at the Engineer Cafe we have 5 Oculus Quest 2s, which everyone can borrow anytime you come here. So even if you don't have your own device, you can still come and get involved. Yeah, so I'm definitely going to be looking forward to all the cool things people make in the VR challenges. And the first one's actually pretty soon, right? The deadline is end of February, you said.
Okay. End of February, yes.
Yeah, nice.
So that's the deadline for the first theme. And we're going to open it up for other ideas. We want to ask the community like what theme ideas. We've brainstormed a bunch to kind of seed it, but we're going to put that into Discord and get people to contribute their own ideas. We'd really love to hear what you guys want to do as like challenge themes. Yeah.
Excellent. Sounds brilliant. Okay, thank you very much. Now we're going to move on to our main talk. If I can, oh, he doesn't know he's on. Okay, I'll set up the slides in one moment, but I'll give a quick introduction to Danilo from Kyushu University and other places. He's a researcher in AI and machine learning and intelligence in general. Some famous work include the one pixel attack, which got a lot of press coverage, but he's not just a one-trick pony, he's covering a lot of different fields. So he's going to give us a talk about intelligence and other things today. I'm pretty excited to hear the contents. So please take it away, and a big round of applause for Danilo.
So today is going to be like something a little bit different from normally what I do, which is just go to many places and talk about intelligence over and over. It's kind of a break. It's called The Impossibles. So I think it's gonna be there. Yeah, it's gonna be like just talking about many things that I did and some of the research, some of the results, and I think that's kind of an introduction from many parts of AI, but not going depth of any of those. So that's okay. So this one is great. So can I change this? Okay, so I come from Brazil, and everything starts on computer engineering. Actually, I hated to program in the beginning. In high school, they presented me Delphi, and I couldn't get along with that. But then I entered electrical engineering, but you're not seeing that here, because actually I gave up on electrical engineering because in 1 year, the first year of computer engineering, in electrical engineering, I came in contact with, at that time was Pascal. And they presented me not that Delphi big board of a lot of difficult things, but just text. And I love that. So that's when I decided to change completely I love programming. I decided that really, if that was programming, then I wanted to do it thoroughly. And that's when I understood that I love that, but I wanted to create robots. So I started with this thing here called, simulation of control for robots in the first year of engineering. It's a long story how I started to that, because I kind of started programming and really get into the thing. And then I started the group, RoboCup group, which is until now I think is running there as an AR coordinator and co-founder. So I was really impassioned with like getting robots to do things that humans do. And then I was in that thing, and I went to Germany, and that's kind of, there are many things that I was looking in Germany, but in the middle of all those things, I was looking for two that I couldn't do in my place. One was, this is like Ulm University, but one was really touching big robots like this. And then that's where I passed like 6 months trying to make this robot walk. And this was 2007, 2008. And then I also, one thing that is not mentioned here is that I love the neuroscience. I still love neuroscience. And I couldn't learn neuroscience in my school because they didn't allow me to take classes. And I did 6 months of practice in neuroscience. So I really opened the things there. I see like many interesting stuff in real brain. So what is this talk called about impossibles, and that's where we're going to start right now. So, but in the end, when I was in Germany, I kind of got that kind of feeling that, okay, Germany is not really where I want to stop. I want to go to somewhere else. And this was Japan in my mind like for a long time. And then I decided to go to Japan when I was in Germany. And then I applied, and I failed. So I had just like, it was in my end of my graduation. So I failed, and then I went to the interview. I had very good things. So as you can see here, I couldn't speak Japanese, but I could read a little bit. I had so many papers. I had like advanced German knowledge, and I have like some, I worked in Nokia, top company at the time. But I couldn't convince my reviewers, or how can I say that? I mean, the people that were trying to evaluate me there, that I could go to Japan. And they said to me, I gotta get a culture shock and come back to Brazil. So I passed like, second year went, failed again. So I just achieved it. I mean, everybody was saying, oh Daniel, it's impossible, you know, like, you don't have any Japanese blood, you don't have anything, you don't know about Japan as much as the people know. And São Paulo, where I come from, it's very competitive. many people from, have descendants, ancestors from Japan there. So they are very strong Japanese. So it took me 3 years, and people were always thinking that I was going to give up, but I didn't. And that was one of the impossibles, I think, in my life. And then, when I was in Brazil yet, then now starting more in the AI side of things, I got some interest in multi-objective optimization. What is this? It's basically what's written here. You have 2 or more objectives. So for example, when you want to buy a car, and you have the cost of the car and the speed, so you have to there's a kind of a trade-off there. Because if you got a very cheap car, it probably is not going to be that fast. And if you get a very fast car, probably not going to cost so little. So there's a trade-off, and that is where you see there. Those points in the we call that Pareto front, which means that all those points in that line, they are better than all the other points inside that, because they are either cost less or they are faster. So, but that's just basically the definition of it. And I was very interested into that. And my challenge was, could I make something that could surpass everything? Remember that I was talking about RoboCup and robots, and now I'm talking about multi-objective and objective optimization. So I understood in the end of my graduation that robots could not do anything if I just couldn't manage to understand optimization and AI by itself. And optimization is kind of the heart of AI. So this is kind of the reason why I started researching this. And so here you see some drawings of how we could divide. So it's basically dividing the things into many different subpopulations, and then you get these things this is kind of explanation of force. I'm not going to go into details, but the thing is that I got a better algorithm than everything before. And this was published in a prestigious journal in the area, 2000, and I don't remember the number, 2014, 15, I don't remember. And then actually what's fun is that it's still in the state of art. It can still compete with most of the state of art until now, and we just developed a better algorithm than this using machine learning actually in the middle of optimization, and it beats everything, and we just submitted to a conference just last week. So yeah, we're continuing that, but this was kind of really big challenge, and I'll call it almost impossible thing that I just got in my mind to try and see what happens. And then let's go to the next thing, which is adaptive AI. So what you can see here is the top universities competing in the DARPA challenge. So the robots are trying really hard to do things that we do for very easily. But as you can see, what they show normally in TV is the things that they achieved, but not the things that they fail to. So those are examples. This is from Boston Dynamics. It's even written there, so the robot failing badly. So what this means is that all those very complicated AI teams, when you change a little bit the environment, they start to misbehave. So that's the current AI. And in 2013, I developed this kind of thing it's kind of automatic state-accurate adaptation in the left side, in the right side. So inside of each of those blocks, you have a kind of specialized neural networks. So which means that every different, so you can think, how do you understand that? When you're working on something, one part of the network is activated. When you're working on another thing, so for example, if you're playing soccer, there's one network for that. When you're then cooking, there's a network for that. So you don't mix those things, and that's how it gets very adaptive without having problems changing between subjects. So with that, we could make it learn, oh, this is Japanese, I forgot to change, dynamic mazes. So I think the top one is the one that attracts a lot of attention, but the hardest one is the one below, which is actually making, this is a maze. So the left side have a wall, which is the gray, and the black is the objective. A robot has to go to the objective passing through the maze, and the maze is changing during the learning. So it has to perceive that the maze has changed and change his observation. So this is really hard for machine learning even now and even today. It was pretty easy to solve with this type of algorithm. So it was published in 2013. Yeah. And then we have to general AI, which is a common topic recently. For example, we have most of the publications in AI kind of failing badly in both, either adaptive AI, either they are not adaptive or they are not general, or they are not both. So those are the two challenges that we still have in tune today. And this is a system that, so basically my challenge was, can I create a system that can solve above is reinforcement learning? It's one type of problem. Here below we have functional approximation, which is completely different. It's completely different problem. It's not even the same way that we represent things. And in the right side, you have something similar to functional approximation, but for a time series. So can I create a system that can be employed without changing anything? I don't want to change any parameter. Just put there, plug, and let it learn. Can I make this happen? And my answer is, it was obsessive, but yeah, my answer is yes. If I can make something similar to the brain, brain has many different types of neurons. And we don't use all neurons for all our things. They are specialized. If we can create then different types of neurons and let the network choose which neurons to for each job, then it can learn to specialize it by itself. So that's what we did. And that's actually one of the greatest impossibles in my life, because when I presented this to my supervisor, he said, like, you're not going to be able to program this thing. This is like, it's crazy stuff. I said, well, I can try. And yeah, here we are. Actually, my student couldn't make this thing become Python. This is in C still. The last version is C because my student couldn't put it in Python. So it seems the code is hard. So it has all those features, neural-modulated connections, excitation inhibition, multi-scale, slow, fast neural, diverse types of activations, learn that changes. Anyway, so it has all those features that you see in many different types of networks, but it has everything into one. So it's a unified model. Anyway, so this is something that was pretty impossible. And then we see here like a board game, Go board game, and humans failing badly against machines. And free against zero. And one of the things people don't realize in this is that these machines are actually not smart at all. You get the same board, and you say, okay, not going to play with the 13 by 13, or I think it's 13 by 13. Let's get a smaller one, 9 by 9 or something. And the machine just can't play. Any Go player can play smaller. A machine can't. Where's the catch? So the catch is that machines are not adaptive at all. They don't understand what is a Go. They don't understand what is the position, that thing, and that's the exact position. If you change things, it gets completely, it doesn't know how to transfer knowledge. So they are very great though. So then we have this one pixel attack, which Laurie talked about. And it's basically the idea of let's put one pixel there. But let me try to just talk about the story about that. I was trying to think about, okay, we knew by that time that the machines were subject to being fooled. So we knew that we could add noise and make the machine, misclassify. But the question was, how much we need as a noise? When, I did a lot of research on optimization, and I knew optimization was very strong. And then I said to my student, okay, let's try with 1 pixel. My student said, you're crazy. We have just 2 computers. We cannot be wasting time. I said, well, okay. And then next week I said again, have you tried with 1 pixel? I said, no, it doesn't make sense. And I've spent 2 months to convince him. And I remember that after the second month, he said, like, hey, it worked. What worked? The 1 pixel. And that's where we got the 1 pixel attack. So it's basically like the idea of trying to search for a specific pixel in that image that can make it misclassify. So what is normally recognized as cat, if you change 1 pixel of the image, it can become a dog. And why this happens? Well, that's not very complicated to explain. Well, it's complicated to explain if because of the details in between the code, but yeah, actually the machines are just processing the patterns in every place of the image. So when you change a pixel, you're actually activating a lot that place and make that place very important. But I'm making the neck of a cat very important, and that changed completely the classification. So in summary, that's how we make machines misclassify. We just change the attention of machines. It's like making a light blink on the side here. You just can't help but look here. That's what we're doing. So this thing really got everybody by surprise, even my student. And recently, so this year, we are going to receive an award there, hopefully in Italy if I can go. Let's see. So yeah, those are the impossibles that I did, but there are more to go. That's what I like to do. I like to kind of see what can be done. It's not like, okay, I'm gonna success every time I try. No, not at all. Those are the successes that I'm showing. They are the failures. I even want to make a presentation about the impossibles, but this time around, the things that I failed, and there are much more to talk about. And there are new impossibles that we're trying. Is like I'm very excited about the middle one, but that's really hard to talk about. But yeah, that's the middle one. So I mean, as I said before, I understood that optimization was very important for AI, and then I gave up everything about robots and I started learning optimization. And then after I learned optimization, I said, okay, I'm very good at optimization. I'm going to go for AI, and then I focused just on AI. But recently I said, I don't think brains optimize. I don't think nature optimizes. I don't think the universe optimizes the way we do. I mean, we have evolution, yes, but it's still very different. It's still very slow in terms of how the brain works. I felt like maybe it's different. Maybe what the brain is doing is not really optimization. But if it's not, then what is it? That's where I started looking for 1 or 2 years ago, 2 years ago maybe. Then, well, it's a long story how I get to this strange thing that was in my mind for, I think, 3 years or so. As I said, like, that's the successes. But before doing that, I had failures with that code. This code was implemented in 2 days, but I failed coding this for months. All right, so when I said, no, I think I know the equation, and then I got there and make it right. So what this does is actually we have chunking here. We have a sequence of letters that's like that. So this is the state machine, right? So it has A goes to B, or A can go to B, or it can go to C. And then after it goes to D, it has D, E, F, and then it enters another chunk. So basically we have 2 chunks that are kind of probabilistic, and in the middle we have a chunk, D, E, F, which is sequential. There are 2 different types of chunks. And what we do is just let the machine learn, and it's going to identify that there are 3 chunks autonomously. More interesting, I'm not interested in things that just get, learn and then stop doing everything, because we don't see that in animals. So what I did is like, okay, let's change everything in this structure and see what happens. And it learns again. And, well, cool, very cool, interesting. But what is more interesting than that is that I mentioned before, I was interested in something that didn't have loss functions or optimization, and that's it. I'm not showing the details here, but actually it's just 2 dynamical equations. They are dynamical equations. They are not optimization at all. They self-organize. It's like when you create a crystal, right? And they are self-organizing to create that crystal. That's what we're doing. So it's, yeah. And it's pretty crazy stuff that it was accepted in AI, which is one of the top conferences in AI. And I think the top is the biggest conference on AI field, not about neural networks, it's about everything. And those are the results. It's actually surpassing even the deep learning, which is Word2Vec there. So as you can see, it's pretty precise, even though it's really strange stuff. It's just dynamically changing attractors. Actually, it's what you have here, if anybody knows about chaos theory, it's not a tractor, and it's not what's the name of that? A repeller. It's both attractor and a repeller together, which is kind of conditional. So it's a little bit crazy chaos theory here, and we don't even understand completely, but we are understanding more and more. So that's one of the things that I'm doing in my lab mostly, trying to get into this new idea of new AI paradigm. And I also want to challenge myself with other impossibles. Here we have in the left side, can we build something like in psychology that is kind of general, not talking just about, humans? Can we make something, more extensive? And actually we already have this almost done recently with Megumi. And then have here something that I'm starting with this right now with a friend from Kyushu University, but he's from the medical department. So this is actually those photos were taken from me. So I took those two. This is like very, very cold. The cells there are like stem cells that are like just frozen, and then we can take them out and make them, just how can I say, beat, so they start to live alive. And this is an experiment that he was doing before me, but I did all these experiments as well. So I was training my skills for doing these experiments in my lab. So anyway, so learning to do experiments on stem cells, which I found so cool. And then, well, there's this new type of AI that I talked about, and this is actually working. And this is one of the last things that we did. It's a hierarchy. It's learning hierarchy. It's not just a thing. There's MidIX. How much time do I have? How much time do I talk? No time? Okay, so, and there's MidIX. MidIX is also another impossible thing. And that's also from one of my advisors said, it's impossible. We cannot be CEO of a company while working in a lab. So that's also from my, we're going to talk a little bit about that. The one pixel attack, people normally look at this and say, it's a deep neural network vulnerability. And I say, yes, but not quite. Then nobody gets it. And I said, it's, if you look at what it is really, the people start programming. And then you have accuracy. And then they publish the paper. And somebody in the next month or the next 6 months, they're going to publish a paper that is better than that. And the accuracy goes up. It's like a stock market. It's inflating. And then somebody sees that accuracy, say, okay, 8.6, now I'm going to make 8.8. Then they make it 8. And then comes another guy and says, no, I can make it better. I can make 90. And they put more mathematical equations. They study the mathematical equations. They go very deep into the thing. And they're 90. And it goes on and on and on. And then we have right now 99. And then everybody says, oh, it's perfect. Now let's go to the next job and the next problem. And I say, not really. What we just created is a social, single objective society. Just focus so much in optimizing one thing and forgetting about all others. That's not happening in nature at all. Nature never optimizes just one side. So what I think that one pixel really shows is not vulnerability of machines. It's our vulnerability. And that's something that I want to tackle. And how can I do that? I have a vision. So my vision is like, normally we have many big problems in society. We have intolerance, we have prejudice, we have harassment, we have depression, we have over-concern. But I think those are not the problems. I think those are the symptoms. And what I want to really tackle are not the symptoms. It's like just going to the doctor and say, oh, it's hurting my brain. I know it's hurting here. And say, take this medicine. It's going to make you not feel the pain. But it's going to come along. So I wanted to really tackle that. And I think it's not possible to solve this. I don't think it's possible to just have zero everything. But I think it's possible to, decrease. And I think what we should be focused is satisfaction. It's in fun, knowledge, interpersonal relations. So deep interpersonal relations, right? The bonds. And I think those are the foundations, I think, of society. There are many more. So can I really work on those foundations to improve us to the next level or just improve in general? So that's MidIX. And that's what I'm trying to do. And just put a name here, which is just can be misunderstood or whatever. It's just a name towards intelligence, is self-aware, self-organized society. But anyway, so that's MiraX.org, and that's our first project. So MiraX has this big, huge, impossible objective, and there is a small, impossible below it, which is the Tech Gym, which is just basically trying to teach everybody to AI and technology. So basically trying to create AI engineer in 1 year. That's objective of Tech Gym MiraX, and we are launching hopefully this year. So keep an eye on that. So that's it. That's my talk. Thank you.
Great. Thank you very much. Yeah. I guess we have a bit of time for questions. Are you okay for time? Because I know you have another event.
Yeah, it's okay.
or something.
It's all right.
Okay.
40 minutes.
Anyone got a question you'd like to ask?
What are some? Can you hear me? What are some possible real-world applications you'd like to see from some of the work you're doing?
All right. So you're talking about how the research can go and breach out in the real world. Right. Tough question. There are a couple of things that can be done. For example, the multi-objective algorithm, for example, can be used in many ways for companies. For example, in one application would be decision making for entrepreneurs. So they have, like, I don't know, 10 KPIs or 10 features they want to modify there. And the machines can find for them some choices, or what would happen if they choose those choices. So of course, you need to have a simulation, but combined with the simulation of that, can alleviate the decision making. That's one application, and I think the results of the multi-objective algorithm here shows really a promising in that direction. And so multi-objective can be applied to many things. It can apply to logistics, many cases logistics or power grid, all those things can be all usable in that sense. So that, I mean, objective optimization is such a general discipline that, right? So that's one of the things. And going to AI, I'm very foundation in terms of AI. So we're trying to create a new foundation. And I don't think we're gonna have deep learning disappearing. I think what we're trying to create is a new type of thing. It's a new toaster, and what they're creating is a printer. So the toaster and the printer is gonna be just different things. You just can't compete with each other, they're different. So when we have the toaster ready, I think we're gonna have something that people don't imagine it's possible, but it's gonna be. But when they compare with the printer's gonna be still better in what they do. So they're gonna be still beating us in Go, because Go is really just memory-based search. So anyway, it's gonna be a big breach, I think, on understanding what is really intelligence. Is it just adaptation, or is just what? So there's many different facets of it. Yeah, I think there are many ways of applying, but I give like some dots. Maybe we can talk more on that later on.
That's great. Thank you.
Thank you.
Any other questions or anything? Yeah, go on.
What does this MiraiX mainly do? Teaching AI?
Yeah, so our first project is going to be still not launched. So we hope to launch this year, but objective is primarily based on teaching, so creating IT professionals and AI professionals. Mostly AI professionals, but for creating AI professionals, we need to have like the base on IT. So that's why I'm saying that we have 1 year, and the first 6 months is just create IT professional, and then the next 6 months is to shape it in the AI. So if somebody has already the knowledge of computer programming and so on, can just get in this last 6 months, and that would be okay. That's basically the idea.
So any knowledge man doesn't need to enter this course?
Exactly. So we don't have any prerequisites. Everybody can enter. So that's exactly what we're thinking about, because most of the courses we have out there, and you can see Stanford, you can, all those courses, you need thousands of math knowledge. And the way I see it is that knowledge is not really a requirement for learning or for using the tools that we have around for AI. And not for programming. We can go from another perspective into AI. That's how I see it. All right.
I see. Thank you.
Okay. I don't think there are any questions from the audience on YouTube right now, but if you do have a question and you're listening at home, just post it on there. Has anyone got any other announcements or other business that you might want to mention? Shout outs? No? Okay, well, thank you again so much for your talk, and I'm sure we'll be hearing a lot more in 6 months or so about Mirai X and your projects there. Yeah, thank you very much. Give you one more round of applause for coming. And yeah, stay tuned on the Engineer Cafe. I'm going to end the stream now.